Hi everyone. Today we will discuss the definition of the derivative. Here, this is a y equals f over x. And on this graph, I have 2 points. This is the first point, this is the second point. And the x-coordinate of the first point is x. And next point is x plus h. Since the graph is y equals f over x, if you plug in these two numbers, you can get the y value f over x and f over x plus h, right? So, first, please note that what is this? F over x plus h minus f over x is actually this value, right? F over x plus h minus f over x. The denominator h is actually this value, right? Wow. So please note that this is the slope of the secant line, right? And if you add the limit symbol here, which means this point approaches the first point very closely, right? And when h approaches 0, we define this one is the slope of the tangent line at x, right? And this is the derivative. Okay, this is the definition of the derivative. Now, we will practice some question using this definition. Later, we will run a lot of formula that can be found derivative very quickly. But if you forget the formula, we must come back to this definition always. Okay, so please try to make this whole process as familiar to you. Okay, use the definition of the derivative to differentiate y equals x squared. Let me copy the definition of the derivative first. Limit h approaches 0, f over x plus h minus f over x over h, right? Now your y or f over x is x squared, so limit h approaches 0, x plus h squared will be here, and f over x is just x squared, right? If we plug in h is equal to 0 directly, please note that this is a 0 over 0 form, right? Which means we need some process to find the derivative, the value of this one, okay? So in this case, I will multiply this one first. This is what? X squared plus 2xh plus h squared, right? And minus x squared over h. Note that you have a x squared, you have a minus x squared cancel out. After that, in your numerator, you have 2xh plus h squared, and denominator has h, which means they are all has the factor h. So we can cancel out. This is 1, this is 1, this is h, right? Then let me copy one more time. Limit h approaches 0. After you cancel out, we have only 2x plus h left, right? While h approaches 0, so this will approach 0. So what is left? Only 2x left. Okay. Okay, second example. Very important and very classical example. Let me copy the definition of the derivative one more time. Y prime equals limit h approaches 0 is a definition f of x plus h minus f of x over h, right? Now limit h approaches 0. Since our f of x is a square root of x, if we use here f of x plus h, then you have a square root of x plus h, right? Minus f of x. F of x is just a square root of x over h. If you plug in 0 here, h equal to 0, then the numerator is a square root of x minus square root of x, which is 0. Denominator is also 0. So this is a 0 over 0 form. So, which means we must handle this one. In this case, we can multiply the conjugate form of the numerator. So, square root of x plus h plus square root of x. We must multiply the same thing to your denominator also. So square root of x plus h plus square root of x. Is okay? Now what is the product of the numerator? Can you see that? This is a minus b times a plus b form, and the result is a squared minus b squared. We can use this concept to here. Then limit h approaches 0, a squared, which is here, minus b squared, which is here. Okay? h square root of x plus h plus square root of x. Yes, here positive x, negative x will be cancelled out, right? After this cancellation, on your numerator you have a h, and your denominator also you have a h, right? So simplify this one, which means divided by h here. Good. So limit h approaches 0, 1 over square root of x plus h plus square root of x, right? When h approaches 0, this approaches 0. So you have 1 over square root of x plus square root of x, which means 2 square root of x. Okay, this is the derivative of square root of x. Good. Okay, last example. Now please use the definition of the derivative to find the derivative of y equals 1 over x. One more time, derivative or y prime is limit h approaches 0 f of x plus h minus f of x, right, over h. Now instead of f, I will use 1 over x, then limit h approaches 0 1 over x plus h minus 1 over x over h. Again, if you plug in h is 0, the numerator is 1 over x minus 1 over x. This is 0. And the denominator is also 0. So this is 0 over 0 form, right? So we need some operation for this part. In this case, you can multiply the LCD of the small fraction. In this case, x plus h times x. Definitely we must multiply the same thing, right? Then if you multiply this one to the first one and the second one using this derivative property, don't multiply first, simplify first. So this is a limit h approaches 0. When you multiply x plus h times x to the first fraction, please note that x plus h will be cancelled out, right? So you have only x left. Now when you multiply this one to here, this time x will be cancelled out. So you have x plus h left. Good. And the denominator h, x plus h, x. Good. Now if you eliminate parentheses in your numerator, limit h approaches 0 x minus h x plus h times x, right? Now x and negative x will be cancelled out. So numerator you have a negative h, denominator also you have a factor of h. So you can cancel out this one also, divided by h, divided by h, here, right? Now limit h approaches 0, negative 1 here, and x plus h times x here. When h approaches 0, this part approaches 0, right? So you have only negative 1 over x times x over x squared. Okay, in this small lesson, we discussed the definition of the derivative. Let me repeat one more time. If you have y equals f over x, then y prime is a limit h approaches 0 f over x plus h minus f over x over h. Okay, using this definition, we try to find the derivative of 3 different functions here. If we have x squared, for example, derivative of this one, using the long process, we arrived at 2x, right? And if we have a square root of x, derivative of square root of x was 1 over 2 square root of x. Okay? And one more things, if we have a 1 over x, now derivative of this one was negative 1 over x squared. Especially the second one can be used frequently. The other things can be found using some formula, but I personally recommend if you memorize the second one, then you can find some derivative very quickly. Okay, thank you for watching. See you next time. Bye bye.